It's been a few months since the Hubble Space Telescope made headlines, but it's hardly been off-duty.
After the servicing mission, we get down to the business of trying to actually commission all of the instruments that have either been replaced or repaired.
The first frame is actually a short exposure.
In space, we can't actually handle the instruments anymore. We can't tune them up with our hands. We have to sense remotely what the instruments are seeing. So we expose the instruments to that first light. For each instrument we do that, and that's a rather big deal because it's the first time that we've had light from an astronomical source on those detectors. The first light actually gives us a check of the instrument focus, whether or not the detectors are working, whether or not the image is on the field of view where you think it should be. All of those things that would just give you some satisfaction in knowing that, at least to start, the instrument is in the condition that you want it to be in order to go forward.
In the past, this checkout period would last for months. Doing groundbreaking science was always put on hold. But you know what they say about best laid plans.
Woke up early one morning, saw an email, the comets hit Jupiter, and from that point on, things moved really quickly. It's a rare event. The last one happened 15 years ago. We thought these kinds of things might only happen every 50 or 100 years.
But we're not seeing so much.
We live in the solar system where small things hit planets all the time. We want to know how often they hit, what are the effects, so we can be prepared.
After putting Hubble to the test to peer at our nearby neighbor, it was time to take new images of the skies to show Hubble was indeed back and better than ever.
Carina is this nearby region where a lot of star formation is going on, and there's lots of clouds and dust from which these new stars are being made. We focused on a piece of the Carina Nebula that hadn't been imaged before by Hubble. The best way to describe it is just this pillar of dust. It's a relatively dense region of dust and gas where new stars are forming. When these new stars form, sometimes as they're forming, they're rotating and you can get jets coming out. In the infrared, we get a very different look because there, the more neutral gas and dust is not glowing and it's mostly transparent, but the highly excited gas and dust in this jet is still glowing.
Omega Cen is a bunch of stars that are all held together by their mutual gravity. We're seeing stars at very different phases of their evolution. They start out as regular stars like our sun, and then they go through a transition inside and become really bright red stars. And then they go through another transition and become extremely blue stars. Compared to previous cameras, Wide Field Camera 3 has a much broader range of colors that it can sense.
We chose the butterfly planetary nebula because planetary nebulae are beautiful always and different always, like snowflakes. Each one of them is very different. And also because, you know, this represents the end of the life of stars like our own sun. So it's the fate of our sun in a way. These are also the objects that form most of the carbon in the universe from which we at the end are made. So it is just beautiful images like these that at the end produce all the stuff we're made of.
An equally important aspect of doing astrophysics is the ability to divide your light up into different energy bins through spectroscopy. One of the prime science goals was the ability to look at the gas in between galaxies, which is called the cosmic web. This is the material out of which galaxies originally formed. You look at bright background objects like quasars that act as flashlights that shine through the cosmic web, and you can see the signature of the gas in between as it absorbs light from your flashlight.
And it could be a combination of...
Now that Hubble's passed its checkup, scientists are eagerly awaiting their chance to use what's essentially a brand new telescope. From the Space Telescope Science Institute in Baltimore, Maryland, I'm Mary Estacion.